Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6, gonna present our group project. So this is our group member. We have Asyiqin, Muhammad Akram, Nrl.Asyiqin, and also Aina Shaza. So for the part 1 is the design and implementation of a small office home office Soho, a network with isolated guest access and internal FTP service. So this project is to focus the design a secure and scalable Soho network for a small business with 60 internal users and occasional guest user. The network is divided into two subnets, which one is for internal operation and another one is to isolate subnet for guests who are only allowed limited access to an internal FTP server via XCL. So internal users have full access to network resource, while the guest to internal communication is strictly blocked. So the network design includes IP subnetting, routing configuration, and hardware selection, such as routers and switch, tailored to the organization needs. So the final setup is verified through testing scenarios to ensure that only permitted access is allowed, and the project deliverable include complete topology diagram, configuration file, subnetting tables, SCL setting, and a bill of materials. Alright, next we have network requirements. First is subnetting and network segmentation, which is create two separate IP subnets and assign appropriate subnet masks to optimize IP address usage while allowing future expansion. And second network requirement is FTP server access control, which is deploy an internal FTP server accessible by all 60 internal users, permit guest users to access only the FTP service, and implements ACLs on routers to prevent guest users from accessing any other internal resources or device. And third is hardware selection, which is identify and specify suitable routers and switch capable of handling at least two separate subnets, managing VLANs, supporting SCL configuration, and also providing stable performance for 60 plus connected device. For network requirement also have network testing and verification, which is perform connectivity tests, validate ACL effectiveness, and confirm internet access for both internal and guest users. And last but not least, for under network requirement is security and performance, which is secure administrative access, ensure minimal latency for FTP file transfer operation, and evaluate the network for bottlenecks and redundancy where applicable.
So for the IP network design table, this is the table that shows how the network 199.60.60.0 has been divided into the three subnets to the meet different host requirements. So for the first subnet, which is 199.60.60.0/26 support up 62 hosts and used for LAN. And for the second subnet, 199.60.60.64/28 support the 40 hosts and assigned to the guest network. And for the last subnet, 199.60.60.80/29 support the 6 hosts and used for FTP. For each subnet has its own specific IP address range, broadcast address, and its gateway. For subnet A, which is the organization of the LAN network, devices are assigned a specific IP address within the range of 199.60.60.0/26, and for each staff PC, which is PC1 to PC4, use the subnet mask 255.255.255.192, and it shares the default gateway, which is 199.60.60.1, which is also the router's G0/0 interface, and for switch is assigned 199.60.60.2, and for FTP server operate on the different subnet, which is 199.60.60.80/30 with the IP 199.60.60.81, and a gateway of the 199.60.60.65 indicate its part separate and small subnet within the overall network design. For subnet B, which is allocated for the guest network, devices such as PC guest 1, PC guest 2, and switch 2 are configured within the IP address range 199.60.60.65 to 199.60.60.68 using the subnet mask, and each of these devices use 199.60.60.65 as their default gateway, which correspond to the router G0/1 interface. And this setup is ensure the guest's device can communicate efficiently within their design subnet while staying isolated from the LAN and the other network.
Next, I am Nrl.Asyiqin binti Alimin will explain about physical network design. So, this figure 6.1 shows wiring closet for LAN, gas and server network. Next, this is the overview of the physical design, where router connected with switch 1 and switch 2, switch 1 connected with PC1, PC2, PC3 and PC4, while switch 2 connected with PC5 and PC6. Next, this is logical network design for this project, which is the same as the previous one, but in different design type. This is the overview of switch 1, where it connected with PC1, 2, 3, and 4, and also FTP server. The switch is connected to the router, while this is the overview of switch 2, where it is connected with router also, and then connected with PC5 and PC6, which is guest 1 and guest 2.
And then next we move into network configuration. For the router configuration, the enable and configure terminal commands are used to enter privilege and global configuration modes. The interface is accessed using interface gigabit internet 01 and activate with the no shutdown command, and system message like link 5 change confirm the interface is now out and operational. And next, the switch enters configuration mode using enable and configure terminal, and the hostname is set to switch 1. VLAN 1 is configured with IP address 199.60.0.2 and subnet mask 255.255.255.192, then activate using no shutdown. The default gateway 199.0.0.1 is set to allow remote management and layer 3 communication. Switch to configuration begins by entering privilege and global configuration modes, then setting the hostname to switch to. A range of interface from Fast Ethernet 01 to Fast Ethernet 024 is selected for bulk configuration, and the no shutdown command active all parts, ensuring they are ready for network connection. So this is the setup focus on configuring VLAN 1 on switch 2 with IP address 199.060.0.3 and a subnet mask. The switch is renamed switch 2 The interface is activate using no shutdown, and the default gateway is set to 199.60.0.1. This setting allows remote management and layer 3 communication similar to switch 1. So next we move into PC configuration. So this is IP config for PC1. This is the IP config for PC2. This is the PC3 IP config. And this is PC4 IP config. And then this one is guest1 IP config. And next we have guest2 IP config.
Okay, thank you. Now, I am Nang Aina Shaza binti Jamalulai. Will continue present with the network testing and verification. In this section is with to testing the verification procedures carried out to ensure the network function as intended. Connectivity tests such as ping and FTP access verification were conducted between devices across different subnets. Additionally, access control list (ACL) were tested to confirm restricted access for guest users as per the network design requirement. Okay, in PC1 ping to PC2, we can easily look at 0% loss. So that means it's very successfully ping. So PC1 ping to PC3 is also successfully ping. Thus we can see at 0% loss, so it was successful. And same goes as PC4, successful. Okay, next for the guess one, which is PC5. Ping to PC1 is unsuccessful, as we can see here is 100% loss, so it was successful for us because this what the main objective of our project is. Same goes as guess one ping to PC2 unsuccessful. This also unsuccessful. Guess one ping to PC3 unsuccessfully, and guess one ping to PC4 also unsuccessful and successful for us. And this guess two ping to PC1 unsuccessful. Guess two ping to PC3 two unsuccessful. 3 and 4. Okay. Next is for the bills of the material. The comprehensive expenditure for designing and implementing the small business network setup delineated in this project is total as shown on the slide, with encompassing 6% of sales and service tax. Disclaimer: this is important to acknowledge that all listed prices that have been rounded for convenience and may not represent the exact financial outlay. Next is we move on to part 2, a campus network design for a college. For the project scope, this project is focused on the design and implementation of a campus network structure for a college that includes the main campus and a branch campus. The main objectives of this project are to ensure seamless wired and wireless connectivity, secure network access, and effective IP address to management to and supports both academic and administrative operation. The scope covers the following components. For the two of component, it is network infrastructure design and wireless network requirement. Network infrastructure design is a design a scalable and secure campus network to serve 230 users across three buildings, which is main buildings 1 and building 2. For the main building, 160 users, and building 1 have 20 users, while building 2 have 50 users. This include a branch campus 10 km away with 100 users in a single buildings to ensure high speed internet sharing from the main building to all users. Next is wireless network requirement. This is provide secure Wi-Fi coverage in the lobby of each buildings. Main campus have authentications for authorized personnel only. Branch campus have restricted access for registered students only. This deploy access points with seamless roaming support. This is a campus diagram where we have one, two, three, four buildings. Main building, building one, building two, and branch campus with a server farm. To illustrate the campus layout comprising a main building, which is pink, two nearby buildings, and a branch campus with a server's farm. The main building serving 160 users is the network hub with high-speed internet access. Building one, which is orange, and building two, which is yellow. These two buildings located 500 meter and 100 meter away respectively supports with 20 and 50 users that I mentioned earlier, and include wireless access in their lobbies. Both are connected to the main buildings via wired backbone links. The server farm hosts essential servers in a secure subnets or DMZ. The branch campus 10 km away accommodated 100 users in one building and connects via a one link for secure communication. Network devices like routers, switches, and access points are deployed to ensure reliable high speed. Next is this is network requirement. To meet the business and security needs for the organization, the campus network must fulfill the following technical and operational requirement. One is subnetting and network segmentations. This creates multiple separate IP subnets, one for internal users in each building, one for the server farm which hosts web, email, DNS, and DHCP servers, one for wireless network access in lobby areas, supporting Wi-Fi for authorized user only. This assign appropriate subnet masks to optimize IP address usage while allowing future expansion. Next is server farm access control. This deploy a dedicated server farm accessible by all authorized users across the campus. Permit only allowed use service such as web, email, DNS, and DHCP to implement access control list (ACLs) on routers, firewalls to restrict unauthorized access to the server farm from external or guest network. Next is hardware selections, IP address scheme, and topology design. For hardware selection, identify and specify suitable routers and capable of handling multiple separate subnets, managing VLAN optional but preferred for improved segmentations, supporting SCL configurations and traffic filtering, providing stable performance for 330 and plus connected devices across campus and branch. Next is IP addressing scheme. Define a clear and scalable IP address plan using the assigned address blocks. Assign static IP to networking hardware and server within the server farm. Use the DHCP or static assignment for use device depending on buildings and user group requirement. Next is topology designs. Create a detailed physical topology showing hardware layout and connectivity, such as router, switches, server farm, access points, and device. Create a corresponding logical topology illustrating IP address distributions, subnet boundaries, and network segmentations among all campus buildings and branch. Next is device configurations, which configure all switches and routers with interface IP addresses, routing protocol if necessary, SDL rules for segments, isolation and access control to the server farm. If LAN are used, configure tracking and inter-LAN routing appropriately. Next is network testing and verifications to perform connectivity tests between host routing interface and the server farm. Validate ACL effectiveness to ensure users have appropriate access to servers and are restricted from unauthorized areas. Confirm internet access for all campus buildings and branch user. Last but not least is security and performance. Secure administrative access to network device. Next is ensure minimal latency for critical service such as web, email, and DNS. Evaluate the network for bottlenecks and ensure redundancy where applicable. That's it for me. Now we will go to the next person. Thank you.
Next, I am Nrl.Asyiqin will be explaining about physical network design. So, as we can see here, this is intercity physical network design between main campus and the branch campus. So, for the main campus, we have 5 buildings, and this is the main building. So, we have 2 departments, which is Department A and Department B, where Department A, the switch is connected with 3 PCs, 1 printer, and 1 access point with 2 laptops. While for Department B, we have switch B, which connected with 1 printer and 3 PCs. Next, this is physical network design for building 1 and building 2. So as we can see, the upper side shows the physical network design for building 1, where switch is connected with 2 PCs, 1 printer, and 1 access point. There are also 2 laptops. Next, the lower side shows the physical network design for building 2, where the switch is connected with 2 PCs, 1 printer, and 1 access point, and also 2 laptops. The the right side shows us the physical network design for building 1 block and building 2. Now I'm going to talk about physical network design in CyberLab, which is the 4th building in main campus. So in CyberLab, we have switch, which connected with 2 PCs, 1 printer, and 1 access point, which have connection with laptop. For main campus, we also have server farm, where in server farm, the switch is connected with 4 servers, which is DNS server, web server, email server, and DHCP server. So at the right side, we can see the overview of the server farm. Last but not least, this is physical network design for branch campus. So in branch campus, we have switch that connected with 3 PCs, 1 printer, 1 access point with which have connection with 2 laptops, and 1 router. Next, this is logical network design for this project. So as we can see, there are 6 divisions in this design. So for the green box, it shows the logical network design for branch campus, and the others is the different building of the main campus. So as we can see here, there are 2 routers, which is the branch route, which is the router for branch campus and the main router. So the main router is connected with router at the branch campus and connected with main switch, while main switch is connected with switch at different building. So for instance, the main switch is connected with the server switch at the server farm and then connected with switch A and switch B at the main building. It is also connected with switch in building 1, building 2, and cyber lab.
So for the network configurations, I would like to present about the configuration of the 2 router, which is the branch router and the main router. First, on the branch router, I set the host name and configure the 2 interface. On gigabit internet 0/0, I assign that IP address 199.60.61.2 with the subnet mask. However, there was the error about the bad subnet mask, which indicate that the IP and the subnet might not correct match correctly. Despite this, I active the interface using the no shutdown command. Then for the gigabit internet 0/1, I configured that the IP address 199.60.61.5 with the subnet mask and broth if as well. And I also enable IP routing and add the static routed so that the traffic to the 199.60.60.0/23 network will be sent through the next hook. Next, on the main router, I set the host name and configure the R3 interface. On Gigabit Internet 0/0, I assign the IP address 199.60.60.1 with the subnet mask of 255.255.255.252 and activate it. On the Gigabit Internet 0/2, I configure that the IP address 190.60.60.2 with the subnet mask. And finally, on the Gigabit Internet 0/1, I set the IP address 199.60.60.129 with the subnet mask, and all the interface on the main router were broke successfully using the no shutdown command. However, there is the important issue, which is the interface that should be connected with two router, which is branch router and the Gigabit Internet 0/0 and main router Gigabit Internet 0/0, and it is using the different subnet. So the branch router use the 199.60.61.0/30 subnet, while the main router use the 199.60.60.0/30 subnet. Because of the subnet do not overlap, the router will be able to communicate with each other over the test interface. And to solve this problem, I recommend or reconfiguring either the branch router or the main router Gigabit Internet 0/0 interface, so both of the interface share the same subnet, and this will alone direct communicate between the router and ensure that the static routed configure on the branch router can be work properly.
Network testing and troubleshooting. This section describes the procedure carried out to test, validate, and troubleshoot the campus network infrastructure. The purpose is to ensure full connectivity, proper configuration, security enforcement, and reliable performance across both the main and branch campuses. Network testing procedure. A series of tests were conducted after implementation to verify that the network components were configured correctly and functioning as expected. Connectivity testing. Ping tests were used to confirm basic network connectivity between devices. Tests conducted between hosts within the same subnet, between hosts in different buildings, between users and the server farm, between main campus and branch campus devices. Expected outcome relies replies received with low latency. ACL testing. ACL rules were verified to ensure they were properly restricting or allowing traffic. Tests conducted attempted to access the server farm from unauthorized devices, access allowed services from authorized users. Expected outcome. Access control rules performed as intended with no unauthorized access granted. IP addressing verification. Both DHCP and static IP address configurations were tested. Tests conducted verified IP addresses assigned to user via DHCP. Confirmed static IPs on routers, switches, and servers. Commands used. Uh, one for Windows and one for Linux. Expected outcome. Correct IP addresses matching the design subnets were assigned to each device's internet access verification. Internet connectivity was tested to ensure all users have access via the main campus router. Tests conducted open website and ran DNS solution checks, expected outcomes successful internet browsing. Wireless connectivity testing, Wi-Fi performance and authentication were tested in lobby areas for each building. Test conducted verify signal strength and roaming capability. Test WPA2 enterprise means when campus and restricted access means branch campus. Expected outcomes: stable Wi-Fi connections, secure authentication, and seamless roam between APS. Troubleshooting activities. Issues encountered during deployment were resolved using standard troubleshooting methods. No connectivity between devices. Diagnosis check critical cable, switchboard lights, and interface status. Solution replace faulty cables, ensure correct port configuration, and belong assignment. Incorrect IP assignment diagnosis, review DHCP settings and address pool solution. Correctly DHCP scopes, restarted DHCP service or manually assigned IPs. Server inaccessibility diagnosis, use ping and trace route to test reachability to server form. Solution, use SQL rules correctly. Routing paths are restricted uh, the affected services.
So last but not least, for part two is the bills of materials, where the comprehensive expenditure for designing and implementing the small business network setup in these projects around total 395,102 ringgit 10 cent, encompassing a 6% SST, which sales and service tax. So for disclaimer, it is important to acknowledge that all the listed price that has been rounded for convenience and may not represent the exact financial outlay. Thank you.